In the last video, you learned about truthy and falsy values in JavaScript. This is actually part of a bigger language feature called Type Coercion. This is allowing us to take a value of one type and in a specific context, automatically translate it over to a value of a different type. For example, here we take an object or undefined and we coerce it into a Boolean value, either true or false. Now, when it comes to truthy and falsy, this is the one situation where type coercion is actually what we want. There are a lot of other situations where we're going to get very strange and unexpected behavior, and I do want to take a few minutes to talk about that. Let's make a new file over in the advanced directory for this one. I'm going to call this one type coercion.js. And in here, we're going to mess around with a few situations where we're probably going to get values or output that we just do not expect. I'm going to kick things off with a console.log, and inside of here, we're going to add a string. Let's keep the string's contents to just digits. I'm going to use 5. Then, after that, we're going to add the plus operator, and we're not actually going to put another string here. We're going to put a number here. So here we are trying to use the plus operator with two different types, a string and a number. So we probably have a few questions. First up, is this program going to crash or is it going to actually run through? If it runs through, what value are we going to get? Is that plus operator going to be used in the context of the string, performing string concatenation, resulting in 55, or is that plus operator going to operate with respect to the number, actually converting the string to a number, in which case the result would be 10? Well, we can actually figure out exactly what happens and why by running the program. Over inside of the terminal, let's run this file, no type coercion.js. When I run the script, what do we get? We get 55. So this is an example of JavaScript not being 100% sure what it should be doing. So it takes its best guess at what behavior you want. And now type coercion in this fashion is typically something we want to avoid because we're going to get extremely inconsistent behavior. Down below, for example, console.log. Right here, we are going to add a subtle change to the line above. We're still going to start with a string with the digit 5 inside. This time, though, instead of using the plus sign, we'll use the minus sign. Then we're going to set up the number 5 afterwards. So the only difference is that I've swapped out the plus sign for the minus sign. Now, once again, we have to guess in which context is this going to operate. Is it going to operate in the string context or the number context? Well, there actually is no situation where we subtract two strings like this. With the plus sign, we did have string concatenation. With the minus sign, we do not. So it's actually going to operate under the context of the number. We can prove this by saving the file and rerunning things over inside of the terminal. Right here, we get 55 for the first one and 0 for the second one. So it took our string, it converted it to a number, and then it subtracted that number from the other one. So this is the inconsistent behavior I was talking about. If you saw this line and you knew it printed 0, and then you saw this line, you'd probably guess it prints 10. It does not. So we want to avoid any situation where we're trying to perform these operations on values of different types. This is type coercion, and as we saw, it can be very useful when trying to convert things over to a Boolean, but when it comes to our other types, it's typically something we want to avoid. We want to avoid it with strings and with numbers. So up above, I want to leave a quick comment. Type coercion. There are 3 values you can coerce to. You can coerce to a string, a number, or a Boolean. That is it. We already saw the string version right here. We saw the number version down below, and we saw the Boolean version in the last video. We're going to avoid at pretty much all costs these two. When it comes to converting things to a Boolean, that's okay. This is super common. There aren't as many edge cases, and it's something that most JavaScript developers are indeed taking advantage of. This is where truthy and falsy comes into play. There is another situation where we're going to see type coercion that I want to cover. What I'm about to cover is something that I'm just covering for the sake of completeness. It's something that we want to avoid. So down below, let's go ahead and add a third console.log call into the mix. Right here, what we're going to do is check if the number 5 equals the number 5, and we know, obviously, this is going to be true. I'm going to run the program just for the sake of completeness. As suspected, I get true printing. This is using triple equals. We use a single equals sign when we want to assign a new value to a variable. We use a triple equals sign as our comparison operator, checking for equality, but there actually also is a double equals sign. This also checks for equality, but it does not take type into account. That means that 5 is still going to equal 5. We can run the program with two equal signs and see that we do still get true. But this also means that if I were to change this 5 to be a string, we would still get true. Right here, it's going to try to coerce those two values into the same type, and when it does see that they are equal. So this is going to be a problem because we might get some inconsistent behavior where we have values of different types. We're seeing that they're equal even though they're not. This is why we're always going to be using strict equality with 3 equal signs, which is what we've been using so far throughout the course. This does take type into account, meaning that the string 5 would never equal the number 5. Just to prove things once again, we go from them being equal with loose equality using 2 equals signs to false for strict equality, using 3 equal signs where type comes into effect. So we're never going to use 2 equal signs in this course. I've been writing JavaScript code for about a decade. In the first 2 years, I used 2 equal signs. Ever since then, I've used only triple. If someone tells you there are situations where you want to use loose equality, they're lying to you. There is no need to ever use it. There's a lot of inconsistent behavior, as we just saw, and we want to avoid it at pretty much all costs. Triple equals is the only way we're going to check if 2 things are truly equal. Now, if working with values of different types can result in very unexpected behavior, one thing we're probably going to want to add to our code is a bit of type checking. If a value comes from somewhere else in the code, we might want to make sure it's of the type we expect before we start using it. For example, if we're expecting a number, we might want to confirm it's a number before we start performing math operations on it, because as we can see, we might get a result, even though it's not the correct one. To check the type of a given value, we can use the type of operator. So for example, type of, all lowercase, one word. After type of, it's a space followed by the thing we're trying to check the type of. Maybe it's a variable, maybe it's an argument. In this case, let's just explicitly type something out like the number 123. So what is the type of 123? Well, that's a number, and what comes back from the type of operator is a string that lets you know of what type the value is. In this case, it would be the string number. We can prove that right here. Const type equals whatever comes back from that operator. Then down below, console.log type to print the type. Yes, I could have just taken this code and explicitly added it in. That would have worked as well. Now we can save the file and rerun things. When I do rerun them, what do we get? We get the string number printing. And we can check the type of anything: arrays, objects, booleans, strings, and numbers. For example, if I had some object, I could check the type of it. If I save the file and I rerun things, the type that we get back is the string object. So this can be very useful when it comes to performing type checking in your application. We're not going to use type of a whole lot, but it's important to know that it exists. It's going to help us better manage the types inside of our program. Let's wrap up this video by changing our script to make it a little easier to check how type coercion works. I'm going to remove the 3 console.log lines above and create a const called value. And right here, we'll just set up some sort of operation where type coercion is going to occur. For example, I'm going to take true and add on the number 12. Then down below, I'm going to check the type of that value, and then I'll print both the type and the value. I already print the type. Console.log, below that, I will print the value. Now we can experiment with anything we want. We can toss 2 things inside of here. We can see the resulting type and the resulting value. If I run the program with this code, what's going to happen? Well, if I run the script, what do we get back? We see we get a number back, and we get the number 13 back. When we convert a Boolean to a number, which is exactly what we're doing right here, what happens? It actually converts true to the number 1 and false to the number 0. So we see 13 with true. If I switch this over to false, I would expect to see 1 less, and if I rerun the script, that's exactly what we get. And that's where we're going to stop for this one. If this video was mind-numbingly boring, frustrating, and confusing, then my apologies. This is where we're going to stop when it comes to our discussion on type coercion. But it's really important that you know it exists, because as you write regular code, you might run into a situation where you accidentally perform something like what we have above, if you're accidentally passing around incorrect types. What you're going to get back is not going to be an error, so it might be really tricky to actually figure out what's happening. Now that you know a bit about type coercion, you can say, oh, you know what? I bet you those two values are of different types, and that's why I'm getting this strange and unexpected behavior. Now, I could say more on type coercion. There are other combinations that are interesting, but those combinations are pretty much endless. There are all sorts of different variations, and I don't think it's worth creating another 4 videos to cover them. So what I'm going to do instead is link to a fantastic article in the PDF guide for this lesson that takes a very, very deep and detailed dive into type coercion. The article is super, super long, but it is very well done. So if you're interested in learning more, check that out. If you're not, that is cool too. You know enough about it to actually write JavaScript applications. Let's go ahead and continue on with the course, leaving this behind. I'll see you in the next one.